Now the next one, a bit more important part. Here see, think a bit carefully now. Byte B is equal to 10 I am taking. Byte B is equal to 10 I am taking. Here B is equal to B plus 1. Byte B is equal to 10, B is equal to B plus 1. SOP of B I am taking. SOP of B. Now byte B is equal to 10, B plus plus SOP of B. Alright? Seems to be both are same. Can you tell what is the output in the first case and what is the output in the second case? Yeah, 100% pakka. First one 11, automatically second one 11. Think a bit carefully. If in both cases if I am going to get 11, then why I am explaining this one as a separate case? Ayo. First one? First one? Compile time matter. Second one? 11. What is the output? First one? Make sure. So most of the people are going to feel B plus plus is nothing but what? B is equal to B plus 1. Correct or not? B plus plus is nothing but B is equal to B plus 1 like. Okay. Now the point here is B plus plus and B is equal to B plus 1. Both are not the same. Are you getting? Both are not same. There is a difference is there. What is the difference we should aware? So do you know what is the output? I mean what is the difference, right? So to understand this difference, let me explain. So first case compile time method you are going to get an. Second case 11 is the answer. But to understand this point why we are getting compile time method, let me explain another example so that you people can aware clearly, right? Now observe byte A is equal to 10. Byte A is equal to 10. Byte B is equal to 20. Byte C is equal to A plus B. System.out.println of C. What is the output? The people who attended already operators concept, be silent so that the remaining people can think and they can remember the point well. What the answer we are going to get? Yes, byte A is equal to 10, byte B is equal to 20, byte C is equal to A plus B and SOP of C. What the answer by default we are going to get? You know, seems to be very innocent code. Are you getting? Byte C is equal to A plus B. Very innocent. Sir, 10 plus 20 is nothing but 30. SOP of C is a 30 only. But compiler will give left and right. Observe that. What is the reason for that? Okay. Here, A is what type? Byte type. B is what type? Byte type. And what is the plus? Plus is arithmetic operator. If we apply any arithmetic operator between two variables A and B, between two variables, any arithmetic operator, need not be plus and a plus, minus, multiplication, division, modulo, right? Any arithmetic operation. If we apply any arithmetic operation between two variables A and B, the result type is always max of int comma type of A comma type of B. Are you getting the result? Sir, this result is what type? Max of int comma type of A comma type of B. Sir, max of int comma type of A. A is what type? A is what type? Byte. B is what type? Byte. Sir, max of int byte. Which is the max? Int. That's why this result is what type? Int type. Sir, how you can assign int value to byte variable? Int means how many bytes? 4 bytes. But byte is nothing but how many bytes? 1 byte. Sir, how you can assign 4 byte value to 1 byte variable? Immediately compile time error by default we are going to get saying possible loss of precision. Possible loss of precision. Found int require, found int but require byte. This is the compile time error by default we will get. I hope you people can very clearly. So if we apply any arithmetic operation between two variables A and B, the result type is always is nothing but max of int comma type of A comma type of B. Is it clear for all of you? Let me explain here. Let me show this point now. Here byte A is equal to 10 I am taking, byte B is equal to 20 I am taking, byte C is equal to A plus B, byte C is equal to A plus B, SOP of C. Are you getting? Byte C is equal to A plus B, SOP of C. Java C test.java. Have you observed same code only? Seems to be very innocent. Sir, 10 plus 20 is nothing but 30 like, but compiler is ready to give left and right. Have you observed? Possible loss of precision found int required is nothing but byte. I hope are you able to understand it? This is one important conclusion related to arithmetic operators, right? Next, example 1. Example 1. Take this example clearly. Byte A is equal to 10, byte B is equal to 20, byte A is equal to 10, byte B is equal to 20, byte C is equal to A plus B, byte C is equal to A plus B, SOP of C, byte C is equal to A plus B, SOP of C. Possible loss of precision found int required byte. Possible loss of precision found int required byte. Found int required byte like. What is the reason? You know. What is the reason? Max of here. Have you observed? Max of int comma type of A is what type? Byte. Type of B byte. Now, sir, byte. The result is int. Int is 4 bytes. We are trying to assign to the 1 byte variable. That's why compile time error we are going to get. Sir, can you tell how we can handle this compile time error? Yes, I want to handle this compile time error. What is the possibility? Type casting, right? Now, byte C is equal to byte of A plus B. Byte C is equal to byte of A plus B. If I can take like this perfectly is nothing but valid, then what is the output by default we are going to get? SOP of C is nothing but what? 30 itself, right? If I do typecasting, then it will become valid, right? Now just have a look once. If I can take byte C is equal to A plus B, if I can take byte C is equal to A plus B, now have you observed compile time error by default we are getting? Yes sir. Possible loss of precision like, but byte C is equal to byte of A plus B is nothing but byte B is equal to byte of A plus B. 100% pakka valid. The output by default we are going to get 30 itself. Are you getting? We can solve this compile time error by performing what? Typecasting, right? Okay, add this point also. Byte C is equal to byte of A plus B. Byte C is equal to byte of A plus B. SOP of C. Byte C is equal to byte of A plus B. SOP of C. But the answer we will get 30. 30 itself is the answer, right? So this is. So example 1 is a clear for all of you, right? Now example 2. Example 2. Yes, see. Now observe. Consider only this part. Only this part. Byte B is equal to 10. Analogy. Byte B is equal to 10. B is equal to B plus 1. B is equal to B plus 1. Do you know, is it arithmetic operation or not? Yes. The result type max of int comma type of first argument. And B is what type? Byte. B is what type? Byte type. Type of second argument. One is what type? By default, every integral number is of what type? Int type. Now, can you tell what the result, Anna? The result is int. Sir, how you can assign int value to byte variable, right? Regarding B is what type? Byte. Int value to byte variable. That's why what compile time error by default we are going to get here is, can I spell out, Anna? possible loss of precision found int, but required is nothing but what? Byte. This is the compile time error by default we are getting. I hope you people can very clearly. Sir, possible loss of precision found int but required byte. Now just observe this one. Let me explain. So first one, why we are getting compile time error, right? Here see, byte b is equal to 10, byte b is equal to 10, b is equal to b plus 1 SOP of b. Have you observed? Byte b is equal to 10, b is equal to b plus 1 SOP of b. What is the output by default we are going to get? Compile time error by default we will get. Possible loss of precision found int but required byte. So in the first case, why we are getting compile time error? Now the concept is clear. But can you tell how we can solve this problem? There is a way, you know. Completed, right? Only first part. Can you spell out how we can solve this problem? Typecasting b is equal to byte of b plus 1. Is it valid or not? Yes, take this part also. b is equal to byte of b plus 1. b is equal to byte of b plus 1. b plus 1. So give the tick mark for that value. Okay. Now here just observe, but this one is a value. Sir, I am not performing any typecasting. Yes, b plus plus and b is equal to b plus 1. Both are not same. Make sure b plus plus and b is equal to b plus 1. Both are not same. There is a difference is there. What is that difference is? In the case of b plus plus, sorry, if it is the b plus plus, internal typecasting will be performed. Are you getting? In the case of increment and decrement operator, b is equal to type of b followed by b plus 1. Are you getting? B is equal to type of b followed by b plus 1 is nothing but make sure you should aware. I hope. Are you able to understand? Now b plus plus means what? B is equal to byte of b plus 1. That's why we won't get any compile time error in this case. I hope now you can aware. So b plus plus and b is equal to b plus 1. Both are same or there is a difference? Difference is there. So in the case of increment and decrement operators, have you observed? Internal typecasting will be performed automatically, right? So that's all. These are various loopholes related to increment and decrement. Total 5 conclusions came. Can you spell out what the first one? First conclusion. Can you please cross check? Increment and decrement operators applicable only for variables but not for constant values. First one. Listing of increment and decrement operators are not allowed. Second. Next, the third one. For final variables, increment and decrement operators not allowed. Next, fourth one. We can apply increment and decrement operators for every primitive type except a boolean. Is nothing but like. Last one, difference between b plus plus and b is equal to b plus 1. In the case of increment and decrement operators, internal typecasting will be performed automatically. We are not responsible to perform explicitly, right? I hope is clear, right? So now by this time, I am sure you can aware why operators concept is very difficult. Are you getting? There are internally several loopholes are there. Compulsory you people should aware clearly, right? I hope clear for all of you, right? Okay, this